Hello.
Hello.
Hi.
Uh,
Good morning.
uh, Morning. We will have mock interview. So before doing that, do you mind briefly describe your expectation on the interview?
Yeah. I'm going to be interviewing for Google Onsite, L4 level,
Okay.
and it's going to be uh, like they told me there's going to be three coding questions and one Googliness and leadership round. So for this one, I want practice with the coding part.
Okay. Sorry. When you mentioned three coding questions, you mean three coding rounds, right?
Yeah, three coding rounds. Sorry. Yeah, three coding rounds and one leader Googliness round.
Sure. Let me give you a question here. Let's see whether like you encountered this before.
Okay.
Yeah, I just pasted it here,
Yeah.
and I can walk through this question for you like briefly. Uh, we want to create a string of length n,
Okay.
and to construct that string, we only have four kind of characters to use,
Mm-hmm.
which are A, B, C, and D.
Mm-hmm.
And our character set it only contains A, B, C, and D. And
Mm-hmm.
we also have a cost array. And the cost array is two-dimension integer array, and the first dimension is always n. The
Mm-hmm.
second dimension is always 4. So it means the cost to put each character on each position, meaning it's per position per character's cost. Let's see the example in line 9, which is the cost array, which is 2 by 4.
Mm-hmm.
And it means we want to construct a string of length 2 using A, B, C, and D.
Mm-hmm.
And let's say the position starts from 0.
Mm-hmm.
And if we put A, B, C, and D on the on the zeroth position, the costs are 2, 3, 4, and 5, given by the zeroth row of the cost array.
Mm-hmm.
And if we put A, B, C, and D on the first position, the costs are 7, 3, 4, and 1 separately, given by the first row of the cost array. So that's the
Mm-hmm.
meaning of the cost array. And we have a restrict that we cannot use the same character uh, like on the two neighbors. Basically, the string you construct cannot have like AA, BB, CC, or DD as the substring, and that's the only restrict we have. Our
Mm-hmm.
goal is to construct the string of length n with the minimal total cost. So for our example, the string we can construct is AD. So the cost is position 0 we use A, which is 2, and position 1 we use D, the cost is 1. So
Mm-hmm.
the total cost is 2 plus 1, which is 3, and we need to return the integer 3 as this example.
Okay. 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 Yeah. So what I'm going to do is first I'm going to quickly write down some constraints.
Sure.
Uh, so um, you said that uh, the cost array, the size of the cost, the number of rows in the cost array will
Mm-hmm.
always be equal to n. So
Correct. Uh, this means basically we don't really need n because the cost array, yeah, already has
yeah,
the n as a parameter.
and then there will be four columns. So
Oh, correct.
length of cost of 0 is always equals to 4. Okay.
Mm. Yes.
And uh, can the costs be negative? So
Uh, let's assume all the numbers are positive here.
okay, okay. So and is there a upper limit or is it arbitrarily large? The values they can be any very big value too, right?
Mm, there's no bound, but like we don't need to consider like the total cost is larger than like the
Max.
integer range. So yeah, you don't need to special consider that.
Okay,
But
okay.
so
So
yeah,
I'll assume, yeah, okay. Um, okay. And how large can n be? So can n be zero at all?
No, let's assume all the numbers are positive, including n.
Okay.
And probably let's assume, like, let's say the costs are like less than 1,000, and and the n is less than, let's say, 1 million, less than or equal to 1 million.
Okay. Less than equals to 1 million.
Mm-hmm.
Okay. So that is
Right.
okay. Yeah. Okay. So these are my constraints. Okay. So, okay, the first thing that is coming to my mind is what I can do is for each position,
Mm-hmm.
I can, so for the first position,
Mm-hmm.
so when I'm looking at the first position in the string, since there is no previous value associated, I
Yes.
can pick the minimum cost value from here.
Mm-hmm.
So for my first position, I see, okay, the 2 is the minimum value, which
Mm-hmm.
corresponds to the character A.
Mm-hmm.
Yeah, so I actually forgot to clarify this. So A will correspond to 0, B will
Right.
correspond to 1, and so on, right?
Correct.
Yeah, okay. So for the first character, I can see that, yeah, I can pick A as that has the minimum cost and there is nothing before it. So there is no chance of duplication. Now, when I go on to the second character, uh, I need to make sure that there is no so based on what my first character choice was, I have to select the minimum. So for doing that, what I can do is um, for each of these characters, I can find the minimum cost that I can get. So let's forget that I had picked A in the previous choice. So if
Mm-hmm.
if if in this choice, if I wanted to pick A,
Mm-hmm.
then I cannot consider this, right? Because then it would create duplication. But then I
Right.
have to pick the minimum out of these three. So if I
Mm-hmm.
consider that the minimum out of these three is 3, and this will get added with this current A's cost. So that so to pick A on the second to pick A as the my second character, the
Mm-hmm.
minimum cost that I can generate is 3 plus 7, that is 10.
Right.
Now when I'm picking Now if I want to assess the cost of picking B as my second character,
Mm-hmm.
what I have to do is I have to ignore this and then take the minimum of the other remaining 3. So that becomes 2, and 2 plus 3 becomes 5.
Mm-hmm.
So similarly for C, I have to ignore this, pick the minimum of the other 3, that is 2, so that becomes 6. And
Mm-hmm.
then for D, I have to pick the minimum of these 3, and that becomes 2 plus 1, 3.
Mm-hmm.
So I'm assuming that we only have to return the cost and not the actual string. Is that
Yes.
correct?
Yes.
Okay.
Your idea sounds cool to me. So, uh, what about the type complexity?
Yeah. So in this, what I will be doing is I
Mm,
will start iterating from the second value itself.
mhm,
So in the cost array,
mm,
I will start iterating from the second row,
mhm,
and for each second row, sorry, for each of those iterations,
mhm,
I'm going to look at. Okay, so the first thing that comes to my mind is I'm gonna have to create another 2D array called min cost. So this min cost array will store the minimum cost for the previous iteration. Actually,
mhm,
I think to optimize space, I can have just the previous state, right? So
Mhm.
yeah, I think what I can do is I can have a prev variable. So this prev variable will store the cost zero row. So this variable will store the cost zeroth row, and then I'll
Mhm.
start iterating on this row.
Mhm.
And then inside that, for each of the position, I'm going to look for the minimum of the
Mhm.
other positions in the previous one. But since we are guaranteed that it is the length is 4, that is a constant time operation. So
Mhm.
in essence, what I will be doing is I will be iterating over each and every row, and there are n rows.
Mhm.
Let me think if I'm doing any other operation or not. So basically, it is 4n because I'm doing um, like 4 times. I'm trying to identify the minimum, but
Mhm.
I think the time should be big O of 4n, which is actually considered as big O of n.
Mhm.
And the space, so what I'm doing over here is going to have only like the one row, right? Like the
Mhm.
previous row, and that row has only 4 columns, so that is constant. So I would say space is big O of 1.
Okay.
Does that
Cool.
make sense?
Yes. This sounds cool to me. So, uh, do you mind implementing it?
Yeah. So def, let's say min string cost. Okay. So this function will take in the cost matrix. We
Mhm.
don't need the n value because as we said that we can just take the length of the
Sure.
cost
Makes
and
sense.
match. So yeah.
Mhm.
And oh, this is a tab. I'll use 2 tabs. So n is equals to length of cost. Okay. So I will have to define my previous uh, state as cost of 0. So I know that it will at least have one row, right? Yeah.
Right. Yes.
Yeah. Okay. So I don't need to check that base case.
Mhm.
So then what I do is for I in range 1 to n.
Mhm.
Okay. For I in range 1 to n, now I have to create my current this thing, right? So what I'm going to do is cur cost is equals to cost of I, and
Mhm.
then I'm going to update this cur cost
Mhm.
and then assign the cur cost to prev cost for the next iteration.
Mhm.
So what I'm going to do over here is for j in range um, 4, so cur cost of j is equals to um, minimum of. Okay, so again over here also I will have to find the minimum of the other three. So here what I will have to do is um, okay, so I'm considering for the row I and the position j. So for this position, I have to get the minimum from the previous state. So min prev cost, min prev cost. So min prev cost can be prev of 0, and then for k in range 4, can actually start at 1. Min pref cost is minimum of min pref cost and prev of k only if, because now I have to make sure that um, so if j not equals to k,
Mm-hmm.
min pref cost is this. So when I come out of the k loop, I have the cost for the minimum cost from the previous state for all the three other characters, right? So in this case, what I can do is cur cost of I j e plus equals the min prev cost. And then after this loop, I can do prev equal cur cost.
Mm-hmm.
And then what I can do is I can return. Uh, okay, so for at the last iteration, prev will become the final one, right? So like,
Mm-hmm. Right.
yeah, prev will be the last, considering the last row.
Mm-hmm.
So I have to return the min out of that. So I have to return min out of prev. What I can do is I can quickly do a dry run of this and check if it works or not.
Okay. By the way, what's the dimension of the current cost? Is it? I think it's a one
Oh,
dimension
yeah,
list.
yeah. Yeah, yeah, sorry. Current cost is a one-dimensional list.
Mm-hmm.
I don't know why I did that. Sorry.
Uh,
So yeah,
Final question. Why k starts from one basically? Why you like skip zero there?
because I assigned
Oh,
the
okay.
zeroth value over here.
Okay,
Yeah,
that's cool.
current cost. Okay. Is it fine if I do a quick dry run?
Uh, sure, you can do it right, but yeah, I think my question is like I know you have line 34, right? And like, but J can be like J maybe zero as well, right? So your mean previous cost may not be valid.
Oh, okay, 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 okay. Yeah. So okay. Yeah. So in that case, if j is zero, then min I can there is a possibility that the next one is also zero and it picks that one up.
All right,
Yeah. So I have to assign it a value that is non-zero. So some other value, right? Basically, any
right.
other value, or I can just get I can just assign it to some very high value, like,
You can use infinity or you can check J here.
and then I can remove this criteria.
Mm-hmm. Sure. You can do a like simple dry run. Probably just use our test case, or you
Okay,
can create
okay,
your own.
yeah, I'll use this one.
Mm-hmm.
So iteration one. Okay, so first let me say prev is 5. Okay, now I equals to 1. My core cost becomes 7, 3, 4, and 1. And for j in range this, so now min prev cost is infinity. Um, let's
Mm-hmm.
see. Okay, min prev cost is infinity. J is now 0. Okay, so now k in range this, like now k is 0. So this won't go in because both j and k are same. So then
Mm-hmm.
k becomes 1. K becomes 1. Min prev cost is this prev of K. So previous of 1 is 3. So obviously 3 less than infinity. So
Mhm.
min prev cost is updated to 3.
Mhm.
Then K becomes 2. We check 4, but 4 is greater than 3, so it won't get updated. Sorry, we have to check in prev. Sorry, prev.
Right. The
So
previous row, not the
yeah,
current.
yeah, current. Yeah, so 1, 2. I think 1 I checked correctly. 3, right?
Right. The values are the same right now. Yeah.
Yeah, right now. Yeah. So K becomes 2. So
Mhm.
4. 4 is still greater than 3, so this won't get updated. And
Right.
then I would go here at the end. 5 is still greater than 3. It won't get updated. So
Yes.
then it would come out of this loop and it would do current cost of J. So J in this case is 0.
Mhm.
Um, so that will be 7 plus 3, 10. So
Right.
this gets updated to 10.
Mhm.
Now J becomes 1 and this becomes, so I assigned previous is equals to current cost. So this becomes 10.
Not really, right? You haven't done the J loop, right?
Oh, yeah, yeah, yeah. I haven't. Yeah, because I'm still inside the for loop. So I
Mhm.
haven't done that yet. Yes. That is 2, 3, 4, 5. Okay. So min prev cost is this. Now, I is still 1. Okay. I think what I can do is like this. J was 0.
Mhm.
Now, J is 1. So current cost equals to uh, cost of I. So that is 7 cost of I. Yeah, I think current cost is still the same, which is 10, 3, 4, and 1. Because, yeah, that hasn't been, but I updated current cost. Yeah, okay, that is fine. I updated current cost. That
Mhm.
is fine. And then the minimum previous cost becomes infinity again because that is how we initialize it.
Mhm.
Um, Now, for k in range 0 to 4,
Mhm.
uh, j is now 1. So for the zeroth one, it will consider this time because 0 not equals to 1. So minimum previous cost is minimum of infinity and previous of k. So previous of 0.
Right.
So that is 2. So here it will be 2. Then it will check with 3, 4, and 5. Since 2 is the minimum, it will keep that, come out
Mhm.
of the K loop, and then
Mhm.
current cost of J, which is J is going to be 1 in this case.
Mhm.
So currently it is 3 and it is going to do 5 over here.
Yes.
So now J becomes um, 2. Current cost is 10, 5, 4, and 1. And min prev cost is infinity.
Mhm.
Then I will come here, I will compare 0 and 1 because j is 2. So basically I won't compare 4. So out of
Right.
2, 3, and 5, the
Yes.
minimum is 2. So this will become 2 again. It will
Mhm.
come out of this loop. So
Mhm.
current cost of j, so j is 2. So this becomes 4 plus this minimum cost. So this becomes 6.
Right.
And the last iteration will be j equals to 3. Current cost is 10, 5, 6, and 1. Min prev cost is infinity. In this case, I won't look at this one and all the other three. The minimum out of them is 2. So this will get updated to 2. I will come outside of this K loop. Current cost of 3. So that is currently 1. Added to, and I'll add the min previous cost to it. So that becomes 3. And I will exit from the J loop. And then previous now becomes the cur cost. So previous becomes 10, 5, 6, 3. And
Mm-hmm.
I now becomes 2. But since our array is only, uh, yeah, so basically I has gone out of bounds now. So we will stop and return the minimum of previous, which is 3.
Sure. Cool. I think you solved this perfectly. Since we still have like about 20 minutes, let me give you another one.
Okay.
Yeah, I just pasted here, and as before, I can go through this for you. So, this time we have a list or an array, and it contains a permutation of numbers 1 to n, meaning each integer from 1 to n occurs once and exactly once.
Mm-hmm.
And you want to sort the array, but the only operation you have is like to select a number and put the number to the end. In other
Mm-hmm.
words, the only operation is like you move a number, an arbitrary number to the end. So when you move the number, all the numbers in the positions behind it will be like just a shift left
Mm-hmm.
because the array cannot have a hole. So you are trying to use the minimum number of these operations to sort the array. Like basically after sorting, it should be exactly from 1 to n. Let's see one example. For the first example, the input
Mm-hmm.
array is 5, 1, 4, 3, 2.
Mm-hmm.
And at the first step, you can just move the number 3 to the end, and it changes into 5, 1, 4, 2, 3. And then
Mm-hmm.
you move 4 to the end, and it changes to 5, 1, 2, 3, 4. And finally, you move the largest number 5 to the end, and it's sorted into 1 to 5. And in this case, you need to return 3 because 3 is the minimum number of operations you can use to sort it.
Mm-hmm. Mm-hmm.
Mhm.
Okay. 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 So the operation is to take a number and put it at the end, and all the other numbers move to the left. Okay. That is the operation. Okay. And the goal is to do minimum operations to make it sorted. Okay. 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 So let me write down the constraints. Okay. Mm, so the array will always contain numbers from 1 to n. Okay. So,
Right.
so length of array is, so length of array, if it is 1, then only there will be 1. Can the length, so it, so length cannot be 0 because it is given that it will always contain from 1 to n. So it at least has to be 1.
Sure. Let's assume it has at least to be 2 because 1 is trivial. 1 is just a return 0 basically.
Okay. And any upper bound or arbitrarily large?
Let's it should be arbitrary large, but like let's just assume 1 million, like 10 6 power of 10.
Okay. And the values can, they can be positive, negative, 0.
No, it's a permutation of 1 to n, so it.
Oh yeah, yeah, sorry. Yes. So got it. Okay. So the values will always be from 1 and
Mhm.
less than equals to 1. Okay. And each of these values will always be present. So
Right.
each of the values in the range will be there. Okay. There won't be any repetition, right?
R- Right. It's exactly
Okay.
like one to n.
No repetition. Okay. And okay. I think that should sum up the constraints. Okay. So the first thing that is coming to my mind is going from left to right, or have, having two pointers, one at the start and one at the end, and if the start the value at the start pointer is greater, then put that start pointer value at the end, and increment the start pointer to the next one. Actually, no, keep the start pointer there because then one will come over here, and the end pointer stays at 5. And then if if the start is actually less than the right, then increment the start and keep doing this while the start is less than the end or the right. The left is less than the right. So if I try to do that in this example, what will happen? So 5 and 2, so 5 is greater. So then I will move 5 at the end. So this will become 1, 4, 3, 2, and 5. And my
Uh,
start is still left is here and right is here.
this may not be correct. Five is too large. If you move that to the end,
Hmm.
like you probably have to move lots of numbers because you need to move five again later.
Uh, so, but since 5 is the greatest number.
R- Yes, it's greater
Oh,
number.
okay, 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 okay,
When
okay.
you move it,
Yeah.
all numbers will be updated.
I get what you're saying. So, there is a possibility that the right will move on to 2, and then I will compare 4 to 2, and then 4 will go behind 5. Yeah. Hmm. Okay. Another idea that's coming to my mind is, since we know the numbers, we
Mm,
should definitely know what position they should belong to, right?
correct.
So 5 is definitely going to belong to n minus 1 position, which is
Yes.
index 4. This is going to belong to index 0. This is going to belong to index 3. Now, the least number of ways to move a number from index 0 to index 3. Okay, so if I see 3, so 3 is currently at index 4, but it needs to be at index 3 over here, and this needs to be over here. Hmm. Okay. But the operation is only that we can pick it up and put it at the end. So, but we need to put it at the end such that no other smaller number is going to be put at the end after it. So the order of putting at the end matters here
Mm-hmm.
if we want to minimize this. So for example, deciding to put 5 at the end first is not a good idea, because then good chance that I will put 4 or 3 behind 5. which will destroy the order.
Right.
So pick the number that has pick the smallest number that is out of position and put it behind. Would that work? So in this case, the example that you showed me, what you did was 51432, which was converted to 51423. So you basically took this number and put it behind. So you went from the right and identified the biggest number that was out of position and put it at the end.
The biggest number.
Uh, uh,
How to define out of position?
Out of position is so a number n must belong to the index n minus 1, and the current index will be whatever it is at right now, right? Like
Mm-hmm.
so, for example of 3, so 3, so 3 should belong to 2,
All right.
but at 0, 1, 2, 3, but at 3. So
But
this
two,
3, yeah,
but two is also out of like out of position as you defined, right? For the first
yeah,
example.
2 is also out of position. So what I'm thinking is the first number from the right.
But why not
Okay,
is
so
two?
yeah, so what I'm trying to do is the first number from the right that is more than. So if I start at 2, I want to check if is this the one that is highest at the end, because I don't want to put smaller numbers behind this. So if it was the highest at the end, then that would actually be. So what if it was 1435? What if it was 1, 4, 3, and 5? So in this case, this 5 is already the highest over here, and then uh, oh, 1, 4, let's say 2, 3, and 5. So in this case, 5 is already here. So, hmm. Or if I can go from the left, and so if I see that 5 is already in its place, then the next number is 3. Is 0, 1, 2, 3. 3 is not in its place. Hmm.
Four is not in the place as well.
Yeah, 4 is also not in its place, but that is the next.
I think two, three, four, like all the middle three numbers are not in the place.
Hmm. So what if for every iteration, what if I identify the greatest number that is not in its place? So in this case, the greatest number not in its place is 4.
But in
And
our test case, like in line 64, the first number is 5, right?
yeah, here. Yeah, yeah, yeah. No, I was just thinking out loud about my approach, and I don't think that approach will work. The other one that I was saying before, where pick the largest from the right.
Mm-hmm.
So
Uh,
yeah.
Go ahead.
Now I'm thinking that I might be able to pick the largest element that is out of place. Now, yeah, I'm thinking on these lines. So that in this example, that can be 4. So that is the largest out of place. Then put that at the end. So what that would give me? That would give me 1, 2, 3, 5, and 4. Okay. Now the largest out of place would be 5.
Uh,
So
I mean,
3.
this is correct, but for our sample, the first sample test case, you already figured out we shouldn't move 5, right? Based on your description, the largest one out of order, which is 5.
Oh yeah, the largest one out of this is 5. So it becomes 1, 4, 3, 2, and 5. 1, 4, 3, 2, and 5. So in this case, then 4 would go. Yeah.
Perfect. Let me give you some hints. So basically, I don't think we should use the position. The reason is that if you move one number, right, the position will be changed. So like all the numbers behind it will be shift left. So
Mm.
the position itself is not a stable, like it's not a stable metric because it can be
Mm.
changed. And even if a number is in the correct place right now, it doesn't mean it will always be there because like you when you move a number, all number will be like shift to fill the hole, right?
Mm.
Yeah.
Yeah,
Let me
because the position is, yeah.
let me ask you some questions to see whether like you have more like deeper understanding on this. And
Mm.
first, like very easy, like very simple question. Uh, do you think we need to move number one, like for optimized case?
In the this test case?
No, for all the test cases, if we want to get the minimum number of operations to solve the array, do you think we have a case to like we need to move number one?
I I I believe that number 1 should always be shifted left by moving other numbers.
Uh, what I mean is, yeah, it can be changed. What I mean is, do you think we need to move number one, like
Okay,
select
so take it from a position and put it at the end. No, I don't think so.
right, use the operation to move number one?
Yeah, you like move some other number such that 1 gets shifted towards left.
Right. What I mean is,
Yeah.
do you think we need to pick number one to move to the end?
No, we shouldn't.
Okay. For the because number one is very small, right? So if we move number one, we probably have to move all the numbers because
Yeah.
otherwise we cannot solve them. And
Mm.
second, like for each number, like do you think we need to move the same number more than once?
No, we shouldn't. If we are
Mm-hmm.
moving the same number more than once, that
Mm-hmm.
means we have completed a full
Mm-hmm.
circle, right? Like, and that means that we have completely missed the optimal way of doing it.
Right. It's not because of circle. I think. I think it's because like if you have to move the number the second time, and then you can just save one time for the first time because like the second time when you move that, no matter where the number is, you just move it to the end. So even if you
Yeah.
don't move it for the first time, it doesn't matter. You will have the same effectiveness.
Hmm.
And like here means like no, like at most once for each number. So the third question is very important. Like for if we have to move a number x, what do you think on the numbers other than x? Do we need to move them or not?
If we have to move a number x, what do you think on the numbers that are larger than x? Uh, so to clarify this,
Mm-hmm.
uh, do we want to move a number x which
Uh,
has
mhm.
larger numbers in the array?
This is like the question is if we already decide to move x, we
Oh, okay.
haven't asked like how we make the decision. Like suppose we already decide to move number x,
Hmm.
what do you think about all the other numbers that are larger than x?
Then we'll have to move them too because since they are larger, they have to be
Hmm.
towards the right of that number, the number x. And the only way that can happen is by taking them and putting them at the end.
Right. This means we have to move all the numbers that are larger than or equal to x, right? If we decide
Right,
on to move x.
right.
So if
Right.
we have a conclusion on this, basically, it means that so for numbers from x to n, we
Hmm.
have to move them, and for numbers from 1 to like x minus 1, we
Hmm.
can keep them unmoved. And our goal is to find the largest x, like we need to move. But basically, the larger the x is, the smaller, the less number we need to move. And you can think about it from another direction. So the larger the number x is, the more number you can keep unmoved. So basically, you can, like, we don't need to move number one, we don't need to move that. What about number
Hmm.
two? In what case you have to move number two? And if you have to move number two, then you have to move like all the numbers from 2 to n. And if you don't have to move number two, what about number three? In what case you need to move number three, and in what case you don't? If you like similarly, if you have to move number three, the answer is just like n minus two. Uh, if you don't need to move number three, what about number four? You can just think about numbers one by one. For each number, you make a decision like whether you need to move that.
Hmm.
The first time you find like you need to move this number, that's the answer because you need to move all the numbers like larger than that. For our example, for example, for the first example, right, the decision we make is to move number three. Then what we really move like are just the three, four, and five. For the second example, it means like x equals to two. So we decide to move number two. Then we need to move like all the numbers larger than or equal to two, which are like two, three, four, and five. So the key point is here is like how to find the x.
How to find x? Yeah. So for one thing I noticed for three here is
Uh-huh.
the left of three is greater and the right of three is less than that.
Mm,
But for any other number, I don't see that.
uh, what do you think? Like if you want to move x, so basically if you want to move x, it means
Yeah,
that the numbers from one to x minus one are already in order. That's the reason
are
you don't
already in order.
move them, right?
Yeah.
Then, like, what do you think? Like uh the list looks like in this case? Like
So
why
the
you don't?
left half of the list is sorted because no, not necessarily. So we want to move numbers from one. We don't want to touch numbers from one to x minus one.
Right, they are not
So
like only these numbers are sorted. There might be like some other numbers in between.
for three, we don't want to touch one and two. So one and two, one to x minus one. Why? So one has to be on. So we are going to move x to n numbers. So that way, what will happen is one one will get pushed towards the left. Uh, the difference between so here n is 5 and x becomes 3. So 2 and yeah, and minus x numbers. Okay.
Uh,
Oh,
take the difference between like the neighbors or whatever because the neighborhood or like the position, like they are not the stable relationships because when you move them, like all the neighborhood or the positions will be changed.
yeah. Yeah, because if we see that we moved 3, right? So the whole positions changed.
The question here is why we like need to move 3. We don't need to move 2.
Yeah. Hmm. So if we want have to larger than x, we have to move all of them. 1 to x minus 1, we can keep them unmoved. So if we were thinking that x is 2, then we would only have to move one number.
Uh, X is equals
No, sorry. We would have to move um we would have to move 2, 3, 4, and 5. So four numbers. And if we move four numbers, then what can we find the distance of one from the number? Because one has to go to this this index. But yeah, you're right, but that those positions are not fixed. So if I find what distance one lies from three, so in this case it's two. And so when I move three, I'm
Mhm.
going to be moving three to n. So I'm going to be moving three, four, and five. So I'm going to be moving three numbers. Oh, okay, but three, since one is on the left of this, I'm putting three here. Five, one, four, three, and two. So two just got pushed here. So one needs to move one position
One need to move one person.
towards the left to come in the correct place.
Mhm.
No, I don't think. Yeah. Then in that case, four would have been a better option, but it's not.
Okay, I think like let's stop here. I can give you the like the answer. I think uh in line 85 and line 86,
Mm-hmm.
but we should consider like what does the sequence or what does the permutation look uh, like if we only need to move x to n. Basically, it's something like this. We have one somewhere and we have two somewhere. So all the dots might be some other numbers, and you
Mm-hmm.
have like x minus one somewhere, and
Mm-hmm.
it's something like this. The largest number you can find in this order, it's not position, it's just order. The numbers you can find, or you can take this as a like subsequence. The numbers you can find, the largest number you can find in this increasing order starting from 1 is like x minus 1. And x is somewhere like in the dots, not in the last position, like not in the last brackets. Because if you find x after that, you will like make it longer basically. So basically, x is like in some position before x minus 1, something like that. And if you really like take our example, it's kind of the reason we don't need to move 2 is like 2 is on one's right. So we have the subsequence of 1, 2, and we don't have 3 on two's right. So we need to move all the numbers that are larger than or equal to 3. In other words, if we delete a number like 5, 4, and 3,
Mm.
the numbers remain like are just in increasing order. And for the second case, it's similar. We don't have 2, we only have 1. On one's left, we don't have 2. So we need to move all the numbers that are larger than or equal to 2. And like if I give you another example, uh, like for example, 1, 5, 2, 4, x 3, 6. Let's see something like this. And we
Yeah.
don't need to move 1, 2, and 3. 1 is here. And on one's right, we have 2. On two's right, we have 3. So we can
3.
keep the three numbers. We don't find 4 on 3 is right. So we need to move like 4, 5, and 6.
4, 5, and 6. Oh,
Yeah,
okay.
basically we just delete them. Like click the array or click the list as like kind
Oh,
of sequence. That's the reason I wrote like what I wrote in line 90. And if you like we agree on this, the code is very simple. Like we just save
go
a counter,
from the, yeah.
and then if x equals to counter, we just plus counter by 1. And here, basically counter is the x, like counter is the x we discussed before.
Yeah.
We need to move from counter to n, so which is length minus counter plus 1. It's something like that. That's the reason I think like the third hint is very important. And
Mm,
basically we need to figure out, uh, like in this way, as I suggest you, like uh, what does the subsequence or what does the permutation look like if we
mm.
can keep them unchanged.
Okay, okay. I understood what you're saying. Yes.
It's something like this.
Yeah.
And to give you feedback, I think for this interview, I will give you a higher because of the
Mm-hmm.
first question. So typically for Google interview, we will have like it's possible that you only have one question, but in
Mm-hmm.
that case, that question might be like a hard level question. And I
Mm.
think that kind of setup like not very popular recently because it's a little bit kind of biased or it's a little bit dangerous to decide everything based on only one question.
Mm.
And so the more popular setup is kind of we will have more than one question. The first
Mm.
one is a minimum level question, for example, like what we have in this interview, and
Mm.
you solve that perfectly. We can give you another question, and the other question might be a follow up of the previous one, or it can be a totally new question. It doesn't
New
matter.
question.
And
Okay.
for the first question, like the ceiling performance, the ceiling rating we can give you is kind of higher because it's very rare to give you a strong higher based on only one question, especially that question is in the minimum level. And that's
Okay.
also the purpose of the second question. And for the second question, we are trying to improve your rating.
Mm.
Meaning, if you solve that perfectly, we probably can change your initial rating from from higher to strong higher or from like weak hair to hair, whatever, depending on your performance on the first question. But it's okay that you cannot solve the second question. Like we just keep the original rating. We don't make we don't make your rating worse based on the second question performance. So
Oh, okay.
it looks
Okay.
like the second question is a bonus, and and yeah, that's the I think you solve the first question like perfectly, and
Mm.
like I'm not sure whether you like the question is indeed the dynamic programming. I'm not sure whether you consider like about that or you just come like you just work out the solution without thinking without thinking it's dynamic programming.
I mean, I saw that I can use the previous results. So, I mean, I had an idea of I may be able to use like a DP array and all that
Mm-hmm.
stuff. But then I thought that this approach is like simpler,
Mm-hmm. Okay.
and it came that this approach came first to my mind, so I decided to go ahead with that. Yeah.
Okay. Indeed, for this question, like some candidates gave me like the result, not the result, the solution for recursion, recursion code, and then like I was just told, like this is just a brute force with memorization. Like in that
Mm,
way, they didn't even consider this as a dynamic programming. And what you mentioned is just a kind of dynamic programming. Uh,
mm.
like uh, I'm not sure like you want to like go more deeper than the solution of the first one since you already got a correct solution.
Yeah, you can give me feedback on my thought process and the code, all
Uh,
that.
like your feedback is totally okay. Like sorry, your code is totally okay. Like I will give you a higher based on so I don't see any concerns based on your solutions. I just
Mm.
wonder whether you want to like how to say that whether you want to think you want to discuss about more on the like dynamic programming perspective?
No, so I actually want to ask you some questions. So, uh, regarding the second question, what pattern or what like type does it belong to?
Uh, I don't want to say like I don't want to say this is a brain teaser, but it's very difficult to like classify this like this kind of question into some classical algorithm. So if we like really need to do that, probably it's kind of like just a kind of array question, which is
Mm.
like very wide. Everything can be array or sequence. So we
Yeah.
have lots of questions like this one, but uh, we cannot classify this question into like some classical algorithm like greedy or like the dynamic programming whatever. So I don't think there's a like a good label or good category for this question.
Also, so for example, like if you were given this in an interview, like what kind of thought process or what trail of thought would you start with to tackle this kind of a question?
I think what you did is like there's nothing wrong with what you did. So it's very difficult to describe how to approach this one, but basically
Mm-hmm.
we need to figure out what numbers are really need to be moved. But we need to consider like how to do that. Basically, as I mentioned, the neighborhood is not stable and the position or the index is not like stable. We need to
Mm-hmm.
find something like that can be globally used. They are not, at least they are not neighborhood, they are not the position. And
Mm-hmm.
like I think for the second question, my expectation is like after giving you like the three hints in line
Mm-hmm.
80 to 88, right? So especially after the last hints in line like 90, if I wrote something like that, uh, like the candidate probably can like work it out because the only thing we need to figure out is how to define how to determine x and like going through the examples like why we need to for the first example why we can keep two and like just think about or when we like just write out what numbers we move, right? For the first one is 3 4 5, for the second one is like 2 3 4 5, and then we know like why
Yeah.
we need to do them or why we need to like ammo the previous numbers, we can figure it out. And like that's my expectation. I didn't
Yeah.
expect that like, the candidate just work it out directly. I think for the second question, it's okay to use some hints,
Mm-hmm.
and which may not really affect your ratings because you already solved the first question. So yeah, I think that's the reason the second question works as a bonus. If after some hints, the candidate works it out, I think it's still possible to get a strong hire based on like the first question.
Got it. Got it. I got it. Yeah.
Okay.
Yeah. I agree with you that after the 87, 88 hint, yeah, I think the thing that I learned from it was always use the hint and the given example and
Mm.
try to identify the pattern. So if I would have done that, like if I would have seen in the first example which numbers are exactly being moved, so I would have clearly seen that the numbers that were moved were only 3, 4, 5. And why is that so? Because 1 and 2 are in what do you say? Like they are the subsequence is in order, right? Like
Right.
1, 2 is the subsequence, the only subsequence that is in order. The other subsequence, which is 3, 4, 5, is out of order, which needs to be moved. And then that becomes your x. The minimum of that is 3. That becomes your x. And then that actually is your answer.
I
That's
think
what,
I
yeah.
go ahead. Please go ahead.
No, no, sorry, you go. I was just done. Yeah.
Oh, I think I hinted you about like we need to find number x, and we can consider that in other direction, like what one is not moved. What about two? So in what case we need to move two, and in what case we don't need to move two, and if we don't need to move two, what about three? Like in what case we need to move three, and in what case we don't need to move three. So like that's a correct direction to go. Like we
Mm.
just consider number from the smallest to the largest one, and one by one to see for each number whether we need to move that.
I
And
don't know.
like, but at the time I think you still worked on like what is that, the first the largest number that are not in the order, and not in the correct position, I think. And like you worked on the which is, I think, which is the first example, right? Not first example, the example in line uh, 63, I think.
Yeah, yeah.
And at that time, I think I already gave you the counter example, like our sample test case. 5 is the number you need to move based on your algorithm. Although you already find the correct test case of line 63, we already have the counter example in line 54.
Mm. Yeah.
Mm-hmm. Do you have any other questions to ask me?
So,
Mm-hmm.
uh, like normally in Google interviews, what are some of the important topics that I should cover? Like I know BFS, DFS, graph, dynamic programming, these are important, but any specific ones that you'd like to tell me?
Uh, Indeed, when I was asked about this question several times, and like what my answer was just like dynamic programming graph plus binary search. The
Mm-hmm.
reason I mentioned binary search is because we probably won't give you a like straightforward binary search question.
Mm.
We may give you a question that is complicated enough, which takes a binary search as a sub step. Like we
Oh,
don't have
okay.
to do a simple binary search directly, but it might be a like intermediate step for a complicated question. But what you mentioned like makes some sense. Like we do have very popular uh interview questions with dynamic programming and graph. I think the reason is that also for Google interview, if you reach the second question, typically the second question is like the code is very simple. So if you figure out what to do, the implementation is very simple. That is because we after you solving the first question, we probably don't have much time. We probably have like 15 minutes or 20 minutes anyway. Uh, that may not be like sufficient to work out a like very complicated implementation.
Mm.
Instead, we'll give you a question like you need lots of analysis to figure out what to do. But after figuring out what to do, the implementation is very simple. Like that's the property of questions like this. And also, uh, for the second question, it's probably okay that you don't have the full implementation because
Mm.
since you solve the first question perfectly, we know that we have the signal that like you can change your idea into the correct implementation. So we don't have concern, or we already evaluate your implementation ability, so we don't need the fully code. And what you can do is kind of you can describe the algorithm using some comments or like even with some pseudocode, whatever works for you. So we don't really need the full implementation for the second question in most
Got it, got
cases.
it.
And like go back to our original question, the reason we have DP and like graph questions, I think it's because for DP it's kind of the second, like it's kind of the second question, like the category of the second question in some sense, because for DP question typically the implementation is not very long, and you need to
Mm.
analyze it the like the structure, the overlap, the sub problems, and like
Mm.
the interaction, whatever. You need to do some analysis to like to work out the final implementation. Uh,
Mm.
like the gap uh between the idea, like not between the idea, the gap between the question itself and the first idea is like a little bit large, but the gap
Mm.
between the idea and the implementation is kind of small. So it's kind of we try to evaluate your ability to like to design or to analyze the algorithm. And for
Mm.
graph question, it's on the other hand, most graph questions in interview are
Mm.
very straightforward. They are not very difficult. For example, just something like the classical algorithm, like minimal spanning tree, like
Mhm.
shortest path, DFS, BFS, whatever. And
Mm,
like when you read the question, you probably already know how to do that. You don't need to do like lots of analysis on the question, but the
mm-hmm.
implementation might be longer than a DP question. So
Right.
you may have like, for example, for DP question, the length of code might be like, let's say 50 50 lines of code, more, or
Mm,
even like less than 50. But for a graph question, typically your code might be like 80 lines of code, or even longer, 100 lines of code. So
yeah.
uh, so I think the purpose of the graph question is we try to evaluate the ability for implementation. So basically,
Mm,
DP and graph are two categories to evaluate the different abilities. One is for like the data structure and the algorithm, like design or invent an algorithm, like how to analyze the time and space complexities. And for graph question, we focus more on like the implementation, whether your code is correct, right? So whether you can implement like a much complicated code, although the idea behind that might be
mm,
simple. So that's the
got it.
reason we have these two big categories.
Understood. Understood. That's a very good explanation. Thank you so much for that.
No problem. Although
Yeah.
the two categories are still very wide, right? So it,
Yeah, they are very wide, but I understood your point. Like, because
mhm.
even while practicing, I noticed that graph questions, when I read the question, I'm able to know that,
Right.
okay, I need to use union find and then maybe change union find slightly uh, over there, and then I can get the answer. And it takes
Right.
some time to implement it. But DP questions are like, I get sometimes stuck on them. But
Mhm.
once I'm able to figure out what to do, the implementation is just like probably 10 lines, 10, 15 lines. Yeah.
Right. The DP question is more like our second example here. Like in some dimensions, right? In terms like the length of the code and the idea behind the code basically. And
Hmm.
like graph question is just kind of straightforward.
Yep, yep, yep. I
Mhm.
totally agree. And that's actually a very good analysis. I'll remember that. Thank you so much for that.
No problem.
Yeah.
Do you have any other questions?
Um, I think no, you covered a lot. Like, thanks a lot for that. And
No problem.
the second question was really good. I learned. I think I
Indeed,
learned a new way to think. Yeah.
it's a real Google interview question.
Yeah.
Although I don't think you will encounter the same one because I think it's already banned because it's already published. I think.
Hmm.
Uh,
Hmm.
but like it's probably like 7 years or 6 years ago. Like you may encounter this question. That's a real Google interview question.
Hmm.
And the first one is not real. The first one is like kind of like I can only say the first one is just a category. Like we know Google may use DP question, and I just
Hmm.
like create one by myself. But the second one is kind of real.
Oh, wow. That's really nice. Yeah.
No problem. Yeah. If you don't have any questions, we can stop here.
Yeah, I think yeah, I'm very happy with the overall interview experience. Thank you
Okay.
so much for taking time to interview me.
No problem. Thank you.
Yeah, yeah. Have a
Bye.
nice day. Bye.
You too. Bye.